Hey there, Math Hoppers! In this video lesson, we will tackle the 45, 45, 90 and 30, 60, 90 special right triangles and figure out how to calculate the exact values for the trig functions of 30, 60, and 45 degrees. So let's just review. Right triangle trigonometry comes down to right triangles and 6 ratios. So here we have a right triangle. We have our acute angle theta. Theta is just a Greek symbol we use as variables for angles. And we have identified the opposite side. The opposite side is the side across from theta. The adjacent side, that's the side next to theta. And the hypotenuse is always across from that 90-degree angle. And so if we have this acute angle theta identified within our right triangle, the following ratios apply. We have the sine of theta, abbreviated sin, and that's equal to the length of the opposite side over the length of the hypotenuse. We have the cosine of theta, that's equal to the length of the adjacent side over the length of the hypotenuse. And we have tangent of theta. Tangent of theta is equal to the length of the opposite side over the length of the adjacent side. Remember from our previous lesson, it is also helpful to know that tangent is equal to sine divided by cosine. So you can think of tangent as opposite over adjacent or sine over cosine. Then we have 3 reciprocal functions. The reciprocal of sine is cosecant. It is abbreviated CSC. It's equal to the length of the hypotenuse over the length of the opposite side, or you can think of it as 1 over sine. It's the reciprocal of sine. All you have to do is flip sine. So we think of it as 1 over sine. The reciprocal of cosine is secant. It is equal to the length of the hypotenuse over the length of the adjacent side. It is abbreviated SEC, and you can also think of it as 1 over cosine. If you know the value of cosine, you flip it and you get secant. The reciprocal of tangent is cotangent. You can think of this as 1 over tangent, or you can think of it as the opposite side over the adjacent side. Or once again, if you know and remember that tangent is sine over cosine, cotangent is cosine over sine. So these are your reciprocal functions. If you remember the reciprocal functions and which function they go with, and you remember your SOHCAHTOA, you can solve any trig problem that comes your way. Now let's get to the exact values for these angles. So if we have a 45, 45, 90 right triangle, we have an isosceles right triangle. We have a 90-degree angle, we have 2 45-degree angles, and the 2 legs are equivalent. And we can use that triangle to find the exact value for the 6 trig functions for 45 degrees. So let's assign side lengths to our legs. Let's choose 1. That's the easiest side to work with. So let's label our 2 legs 1. And we are going to use the Pythagorean theorem to calculate the length of the hypotenuse. Remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So it's going to be 1 squared plus 1 squared equals x squared. 1 squared is 1, so we have 1 plus 1 equals x squared, or 2 equals x squared. The opposite of squaring is square rooting, so take the square root of both sides, and we get x equals the square root of 2. Do not reach for your calculator. We don't want decimal answers. When we're working in trig, we want exact value. A lot of times questions will say, give the exact trig value, give the exact sine value for whatever angle. That means they want radicals in the answer. So our hypotenuse is the square root of 2, and we're keeping it that way. All right, now we know all 3 side lengths. We can determine the exact values for the 6 trig ratios of 45 degrees. Usually here I say identify one of your acute angles as theta, but it doesn't matter which one we identify because they're both 45 degrees. So the sine of 45 degrees, we can see opposite over hypotenuse is 1 over rad 2, right? If we're looking at 45 degrees, the opposite side length is 1, and the hypotenuse is rad 2. But we cannot keep rad 2 in the denominator. Actually, you can when you get to calculus, but up until then, you can't. So we have to do something called rationalizing the denominator, which means I'm going to multiply this fraction by a glorified value of 1 to get rid of rad 2 in the denominator. So I'm going to multiply by rad 2 over rad 2. That just gives me rad 2 over 2. And we're going to do that throughout trig whenever you have a radical in the denominator. So the cosine of 45. Let's think about this. The sine of 45 degrees, we looked at the opposite side length and saw it was 1. If we took the cosine and we looked at the adjacent side length, for either 45-degree angle, the opposite and the adjacent side length are the same. So the cosine of 45 degrees is exactly the same as the sine of 45 degrees, and that should make sense because both the opposite and adjacent sides are 1. So it's 1 over rad 2 or rad 2 over 2. Tangent of 45 degrees. Now, if you remember, tangent is sine over cosine. Anytime you divide something by itself, so rad 2 over 2 divided by itself, you get 1. Or you can think of tangent as opposite over adjacent. Either way, it's 1 over 1. The tangent of 45 degrees is 1. All right, let's work with those reciprocal functions. Cosecant. You have to think to yourself, cosecant, what is that the reciprocal of? It's the reciprocal of sine. So I know sine's 1 over rad 2. So cosecant is going to be rad 2 over 1 or just rad 2. Secant. Secant of 45 degrees. If I know the cosine of 45 degrees, I can find the secant of 45 degrees. So cosine is 1 over rad 2, secant of 45, rad 2 over 1, or rad 2. Cotangent of 45 degrees. Cotangent is reciprocal of tangent. If I know tangent, I know cotangent. 1 over 1, reciprocal is identical. So the cotangent of 45 degrees is 1. All right, so that's how we can figure out the exact trig values. Now, that leads to a 45, 45, 90 rule that's going to work in word problems that you get for these trig in this trig unit. So the general rule is going to replace the 1, and the rad 2, and it's going to put variables there. So we're going to get the 45, 45, 90 rule that looks like this. We have x and x. X represents that isosceles side length, and x times rad 2 is the hypotenuse. You will notice if you put any side lengths in for the isosceles sides, for the two congruent sides in a right isosceles triangle, if you put 2 and 2, you would get 2 rad 2. If you put 4 and 4, you'd get 4 rad 2. If you put 102 and 102, you would get 102 rad 2. So that's how we come up with this rule. And here's what the questions will look like. They'll give you a 45, 45, 90 right triangle, and they'll give you one of the sides, and they'll ask you for another one. So here they're asking us to determine the value of n. We see here that n is the hypotenuse. They have given us one of the isosceles sides, so they've given us 5. We know both of these sides are equal to 5. You could use Pythagorean theorem, but do not use the Pythagorean theorem. Use this rule, because sometimes they're going to make it where you have to know the rule in order to solve the problem. So n is equal to what? N is equal to x rad 2 in our rule. So I know that n is equal to x times the square root of 2. I know x is equal to 5 because it's labeled. So right now I know n is equal to 5 rad 2. Would you have gotten that if you used the Pythagorean theorem? Yes, but the rule is so much more quick. All right, 30, 60, 90, let's get to it. We have a 30, 60, 90 right triangle rule, and right now you're staring at an equilateral triangle. Well, we're going to get there, I promise. So what you need to do is remember for an equilateral triangle, all of the angles are 60 degrees. So I've picked an equilateral triangle with side lengths of 2 because it's the easiest to work with. And what we're going to do in order to model this relationship is cut this triangle in half. Once we cut this triangle in half, we're going to drop an altitude, and we will create two 30, 60, 90 right triangles. So let's just look at one of them. All right, there's our 30, 60, 90 right triangle. So we have same side length of 2, because remember the equilateral triangle had all sides 2. I have a 1 down here because that's what happened when I cut this base in half. I have the 60-degree angle I always had. I have 30 degrees here because it's half the 60 that I used to have. Remember, I cut it in half. And now I don't know my height. And that's fine because we're going to use the Pythagorean theorem to calculate the length of the height. Now remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse. If you know the hypotenuse, do hypotenuse squared minus leg squared. So we're going to do 2 squared minus 1 squared equals x squared. That gives us 4 minus 1 equals x squared. 3 equals x squared. Opposite of squaring is still square rooting. So x is equal to the square root of 3. Square root of 3 is an exact answer. We don't want decimals. We want radicals. So pop that in as your height. Your height is the square root of 3. Perfect. We have found what we needed. Now we can determine the exact values for the 6 trig ratios for 30 and 60 degrees. But we definitely need a clean page. So let's get there. All right, there's our triangle. Remember the sine of 30, opposite over hypotenuse. So I'm going to look, the sine of 30 degrees. It's going to be, let's see, here's my 30. My opposite is 1. My hypotenuse is 2. The sine of 30 degrees is 1/2. Okay, what's the sine of 60 degrees? Sine of 60 degrees is rad 3 over 2. How come? If I look at 60, opposite is rad 3. Hypotenuse is still 2. All right, let's go to cosine. Cosine of 30. Remember, cosine. Adjacent. Adjacent is rad 3. Hypotenuse is 2. Rad 3 over 2. Cosine of 60. If you're looking at 60 and you go to the adjacent side, right? Adjacent from 60, next to 60 is 1. Over the hypotenuse is 2. So the cosine of 60 is 1/2. Now look at the sine of 30 and the cosine of 60. They're both the same. Sine of 60 and the cosine of 30, those are both the same. And that's because you have complementary angles. And that's going to lead to another trig rule later on. But it is cool to notice here. All right, tangent of 30 degrees, opposite over adjacent. It's going to be 1 over the square root of 3. But you know we can't leave rad 3 in the denominator. So we'll multiply by rad 3 over rad 3. And we'll get rad 3 over 3. Now, we need the tangent of 60, opposite over adjacent, rad 3 over 1, or rad 3. There we have it. We have sine, cosine, tangent of 30 and 60 degrees. So the next part should be easy. Reciprocal functions. I don't actually have to do anything but look at the last things I've already solved for. Cosecant of 30. Well, that's 1 over sine. So what's the sine of 30? It's 1/2. So the cosecant of 30 is 2. What's the cosecant of 60? Well, again, it's hypotenuse over opposite, or 1 over sine. So what's the sine of 60? Sine of 60 is rad 3 over 2. So the cosecant of 60 is 2 over rad 3. Or if we multiply by rad 3 over rad 3, we get 2 rad 3 over 3. If rationalizing the denominator is freaking you out, we have a video on that. You want to check that out and just watch that after this. So now let's move on to secant. Secant is the reciprocal of cosine. So the secant of 30 degrees, I already know the cosine of 30 degrees is rad 3 over 2. So secant is 2 over rad 3. Can I leave 2 over rad 3? I cannot. I have to do rad 3 over rad 3. And I get 2 rad 3 over 3. The secant of 60, hypotenuse over adjacent, or just 1 over cosine. What's cosine? 1/2. So the secant of 60 is 2 over 1, or just 2. All right, last one, cotangent. Cotangent of 30. Cotangent is 1 over tangent, and the tangent is 1 over rad 3, so the cotangent of 30 is rad 3. Cotangent of 60, again, think 1 over tangent. What is the tangent of 60? Rad 3 over 1. So the cotangent is 1 over rad 3, or rad 3 over 3. So the 30, 60, 90 right triangle has its own rule. We change it from 1 to rad 3 to, guess what? We go x, 2x, x rad 3. That is the relationship. If you look at this side length, across from the 30 degree is going to be your basic x. It's going to be your variable. It's going to be the base, right? We think of it as the lowest. So across from 30 degrees is x. What's the relationship to the hypotenuse? It's twice as much. Always will be. So that's going to be 2x. What's the relationship to the height? X times the square root of 3. This relationship will always stand no matter what sides you picked for that equilateral triangle to begin with. We could have picked 4, 4, 4, 8, 8, 8. We could have picked an odd number, but then we'd have a fractional base, and we don't want that. So this is the rule you get from doing the Pythagorean theorem on the 30, 60, 90 right triangle. You will have across from 30 will be x. Across from 90 will be twice as much as x. And across from 60 will be x times the square root of 3. So what will these problems look like? Very similar to what we just saw. They'll say determine the value of n. They'll give you maybe the base, maybe they'll give you the height, maybe they'll give you the hypotenuse. So you have to look at what you have and look at what it represents in our rule. They've given us 10. 10 represents our 2x because that's our hypotenuse in our rule. So I'm going to divide both sides by 2 to solve for x, and I see that x equals 5. Once I know x equals 5, I now know that this base down here is equal to 5. They didn't ask me for that. They asked me for the height. So I really have to know my rule. I have to know that the height is x times rad 3. I have to know that rule. So now I have to say x is 5. X times rad 3 is 5 rad 3. That's it. So here's the summary of all the trig functions we learned in this video. We now know the sine, cosine, tangent, cosecant, secant, and cotangent of 30, 45, and 60 degrees. In the next video, we will tackle 0 and 90. Here's what I want you to remember. You're going to get problems that say give exact value. And if you were to put sine of 45 in your calculator, you're going to get a decimal. But there is a way around it. Okay? Your calculator will not give you square roots. They won't give you exact values. You put sine of 60, you'll get 0.866025, and it goes on. But if you remember that these are our special angles, 30, 45, 60. And you remember they can be written as a square root. You square the decimal you get from the calculator. If you square the sine of 60, so the sine of 60 is going to give you this ugly decimal. If you square that right from your calculator, you'll get 0.75. Well, how does that help me? Well, now you know that sine squared is equal to 3/4, because that's what 0.75 is. So if you square both sides, then you can know rad 3 over 2. Square root of 3 is square root of 3. The square root of 4 is 2. So if you get a huge ugly decimal in your calculator and your teacher wants an exact answer, and you remember it's one of our special angles, just square it. There you go. You can get an exact answer from the calculator. Well, that's it for this lesson. If you still have questions, you should be subscribed to our YouTube channel. Send them in and I'll make you a custom video to explain your question. Till next time, Math Hoppers, take it easy.